Introducing the future of energy storage, the revolutionary lithium-air battery. With their incredible potential to achieve over 1,000 plus kilometer EV range on a single charge, these batteries hold the promise of transforming the electric vehicle industry. Imagine driving from Los Angeles to New York City without recharging. Though obstacles remain, significant breakthroughs have been made, reaching an energy density 10 times greater than traditional lithium-ion batteries. Stay tuned as this cutting-edge technology from the PolyPlus Battery Company prepares to revolutionize the clean energy sector, powering a sustainable future like never before. The lithium-air battery, LAB, is a metal-air electrochemical cell that eliminates oxygen from the air at the cathode and oxidizes lithium metal at the anode to produce a current flow during discharge. Such a battery can be electrically recharged by adding an external voltage to reverse the process. Lithium-air batteries have the potential to have an energy density 10 times greater than traditional lithium-ion batteries, because oxygen may be continually supplied from the air rather than being stored in the cell in finite quantities. But there are obstacles to go beyond. Numerous prominent academic and industrial facilities around the world have given this issue a lot of attention over the past 10 years, and as a result, some of the problems have now been resolved. A good cathode that uses a highly active and stable catalyst to improve oxygen reduction reaction, ORR, and oxygen evolution reaction, OER, kinetics, as well as an appropriate electrolyte design, are two key requirements for the commercial viability of lithium-air battery technology. Scientists have created effective catalysts, including monolithic lithium iodide and trimolybdenum phosphide, in their search for a highly active catalyst. In order to provide extended cycle stability, new electrolyte formulations have been created that dramatically minimize side reactions in the battery chemistry. The practical energy density is increased via a catalyst comprising nanocarbon and an improved air cathode structure. The final battery functions in the lab with a high energy efficiency of 90%, an energy density of about 1,500 watt-hour per kilogram, about 8 times better than a lithium-ion battery, and a long cycle life of 1,000. The PolyPlus Battery Company is currently preparing to introduce the first lithium-air battery for commercial use in the USA. A very effective energy storage system is one of the obstacles to the mass adoption of sustainable energy solutions. The most common power source for modern electrical and electronic gadgets is lithium-ion batteries, which have an energy density of 100 to 265 watt-hour per kilogram. Lithium-air batteries have the potential to attain an estimated energy density of 1,300 watt-hour per kilogram in the future, and approximately 500 watt-hour per kilogram in the near future, according to a number of research investigations. Due to their theoretical energy density, which is many times more than that of conventional lithium-ion batteries, making them comparable to gasoline, lithium-air batteries are frequently regarded as the pinnacle of battery. This is so that the batteries can use ambient oxygen and the anode, which takes up the majority of the cell's volume, without storing any cathode-active material. Due to its exceptional specific capacity, 3,842 mAh per gram compared to 815 mAh per gram for zinc. Lithium metal is a seductive anode material for any battery. The clean energy sector may undergo a revolution thanks to lithium-air batteries. They may make it possible for electric vehicles to operate on batteries that are a fifth as expensive and as heavy as those now on the market, allowing a vehicle to drive about 650 kilometers from Los Angeles to New York City on a single charge. Currently, an electric vehicle has a 300 kilometers range per charge. Gasoline is anticipated to have a practical lower energy density of 1,300 watt-hour per kilogram to 1, wastes 70–88% energy due to engine inefficiencies and heat loss. The metal lithium is incredibly light. Absent the oxygen mass, the potential energy density of a lithium-air battery is 12,000 watt-hour per kilogram to 1. The theoretical energy density for lithium-air batteries may reach 3,500 watt-hour per kilogram to 1 while taking into account the weight of the battery pack. Despite having a very high energy density, lithium-air batteries are still being developed because of practical issues. Low efficiency and subpar performance have been the results of prior attempts to create a workable battery. Though the light at the end of the tunnel for commercial production has finally arrived, ongoing research has already produced a good lithium-air battery in the lab that is around 90% efficient and can be recharged about 1,000 times. The presence of moisture and carbon dioxide, CO2, in the air is a serious problem since they have a great affinity for lithium metal and so significantly degrade the performance of the cell. On the cathode, positive electrode, of the battery, lithium and oxygen react to form solid lithium peroxide, Li2O2. Li2O2 is not very soluble in organic electrolytes. Therefore, it crystallizes and soon separates from the solution. These can occasionally be accumulated in large quantities near the cathode, which causes the cell to suddenly die. On the anode, lithium metal crystallizes into dendrites, which are small lithium metal fibers that can short out an electrical circuit, sometimes become electroplated and interact with the electrolyte, etc. In addition to reacting with oxygen in the air, lithium metal also interacts with nitrogen, carbon dioxide, and water vapor. In conclusion, the lithium-air battery stands as a beacon of hope for the future of energy storage. Its impressive energy density and potential for over 1,000 plus km EV range have the power to revolutionize the clean energy sector and drive us towards a sustainable future. Stay updated on the latest developments and breakthroughs in battery technology by subscribing to our newsletter today. Together, let's embrace the power of innovation and pave the way for a greener world. Subscribe now for a brighter tomorrow.